guys, you done number 10, guys? I mean, we did I did eight examples of this kind in the lectures. So you shouldn't have too much trouble doing this. He's done it. Yeah. Done. Alright guys, so if you haven't done it, let me show you how to do example 10, question 10 I mean. Alright. What I'm writing. Okay. So you have this estimated p hat equal to x bar. X bar is just simply the sample mean divided by 1 plus n plus 2. And the first thing is we want to find the bias. Bias of p hat. Now what's the definition of bias, guys? It's the expectation of the estimator minus the parameter you're trying to estimate. Okay? So this is the expectation of okay. Now you know how to deal with this, right? So this will be 1 over n plus 2 times the expectation of x bar plus minus p. Okay. Now now taking the expectation inside, you will get the sum of the expectation of xi plus right. Now I'm sure all of you know that the expectation of xi for a binomial is n times p. Okay, so this will be 1 over n plus 2 times the sum of n times p okay.
What happens with the 1 over n on the brackets?
Oh yeah, sorry guys, thank you Stemma. Yeah, I forgot the 1 over n. Yeah, don't know why. Thank you. Yeah. So this will be now the sum of np is n squared p, n squared p alright. So if you simplify this, you get np divided by Okay, so this is the bias. Now clearly this is not equal to 0. This is not equal to 0. So hence P hat is, are you guys okay or what? Yeah. It's a biased estimator of P. Alright, however, we should look at the limit. We should look at the limit of the bias as n goes to infinity. This guy here, as n goes to infinity, this goes to what?
P.
P, yeah. And this one will go to 0. Right? So the limit of the bias is 0. So you can also say that P hat is an asymptotically unbiased Alright guys, are you okay with this so far? Any questions? Yes?
Isn't the expectation of xi np, not np?
It's n, sorry, there's a correction in the there's a typo in the question, sir.
Oh, right.
It should read np, not m. It should n comma p. Yeah. Okay guys, any other questions guys? Alright. Alright, so this is the bias. Now the next thing we need to do, the question is also asking you to find the variance. So let's see how we can find the variance. The variance of P hat. Okay, the variance of P hat is the variance of x bar plus 1 divided by n plus 2. Alright. Now using the rules for variance, this you can write as because adding a constant does not make a difference to the variance, so this is the same as this. And when you pull out the constant n plus 2 outside, you need to square it. Okay, now taking the variance inside the brackets, you get 1 over n squared times the sum of the variance of xi. Now I'm sure all of you know that the variance of a binomial variable is the following: n p times 1 minus p. Okay, so this becomes n squared p times 1 minus p. Okay, so these two guys cancel, so this becomes p 1 minus p divided by n plus 2 squared, which clearly goes to 0 as n goes to infinity. So both the bias and the MSC, sorry, the bias and variance go to 0. So if you look at the MSC of P hat, which using the property 1 I proved in the class, in the lectures, you may remember that MSC is the sum of the variance of P hat plus the square of the bias. Now we have shown in this example that this goes to 0, and this goes to 0 too. Both of them go to 0. So hence, the limit of the MSC is 0, right? So hence, P hat is a consistent estimator P. All right, is that clear, guys? Any questions on this so far? So we've done question 10. Are you okay with this? Yeah. Can you go to question 9, please, now? Question 9. Question 9 is also on bias and MSC, so it shouldn't be a problem for you. So this is question 9. So we're doing question 9 now. We're done with this.
That's a question.
Yes.
Which one says one button?
On bias.
Yeah, that means it's 0. You said K equals 0.
Now we need to find the bias of theta hat
Yeah.
and find the value for k for which the bias is 0. Bias is equal to 0.
Yeah, but we have this multiplication. If this is not 0, the only way to make it 0 is 1K 0.
No, that's not right.
Alright,
No, remember, this is estimating theta. The first thing you need to do is, okay, before answering, find the bias of theta hat, then I will answer the question.
okay.
Okay, try to find the bias of theta, so then I will show you. You guys okay? You like to do this, yeah? How are you guys, okay? How are you guys doing? Okay. How are you doing? You done question 9? No? How you do?
That's the principal value of x times and 1 over 4 times.
No. That's a plus b divided by 2.
Oh, okay.
It's a plus b. This is uniform, right? Stemma.
Oh, okay.
So the,
Oh,
the,
okay.
the expected
was the variance.
That's the variance, yeah.
Oh,
Yeah. You guys done question 9? It's easy, guys. It's not difficult. I mean, I don't want to say easy, but so you have this is question 9. You have the estimator theta hat equal to k times x bar. The first part is asking you to find the value for k so that this estimator is unbiased for theta. Alright, so what you need to do is to find bias first. Remember, the estimator is unbiased if the bias is 0, right? So this is the definition, right? So this becomes k times the expectation of x bar, which is this minus theta. Now if you take the expectation inside, you get this. Now we are dealing with the uniform variable 0 theta. So what's the expectation? I told you this before. For uniform 0 theta, the expectation of x is what? Theta over 2, yeah. So this will be k divided by n multiplied by theta over 2. I mean, you should look at one of the handouts I gave you at the first day of classes. You will see this formula. It's a plus b divided by 2. Right, so this is k theta by 2 minus theta, and this is 0 if and only if k is equal to 2. So the answer to the first part of the question is that k must be 2. K must be equal to 2 for the estimator to be unbiased. You guys follow? Alright, the second part is asking you for the variance. Okay, so before I do, let me do that on a fresh page. So it's asking you for the variance. So we're looking for the variance of 2 times x bar, right? So this is 4 times the variance of this, right? So this becomes 4 divided by n squared times the sum of the variance of xi. Now the variance of xi is for the uniform is, again, if you look at the handout I gave you, it is b minus a squared divided by 12. So which in this case will be theta squared divided by 12. So this is 4n divided by n squared times n theta squared divided by 12, which is theta squared divided by 3n. Okay, is that right? Okay, and this clearly approaches 0 as n goes to 0. Hence, theta hat equal to 2x bar is unbiased and consistent. Alright, is it difficult, guys? Come on, guys. It's not really difficult, is it? Can you do 7, please? Yes. Okay.
Yeah.
Alright, so question 7 is in
Yeah, I'll just check something.
That's okay. Did I say 7? I said, sorry, I should have said 8. Did I say 7? Sorry, I mean 8, I meant 8, not 7. Sorry. I don't know why I said 7. Know how to count. I meant question 8, not 7, guys. I mean 8, question 8. Sorry. So, yeah, please do question 8, guys. Not 7. let's see how, if you haven't done it already, let me show you how to do question 8, okay? It's similar to question 9, which we just did. So you have sigma squared is the population variance, and the estimator of that is k times the sum of xi squared, and we want to find k so that it's unbiased. So you do the same kind of thing as you did in question 9. So you need to find the bias. You need to find the bias of this, okay? Which is this, okay? Taking the expectation inside, you get k times the sum now what's this guy here? How do we find this? Any ideas?
It's normal distributed, so we can.
It's not normal yet. We are not assuming normality. It's only for the second part.
Yeah.
For the first part, we are not assuming normality.
Oh. This is correct.
Now I'm going to do the following. You'll see in a minute why I'm doing this. You see what I've done here? I have subtracted this term and added the same term. The reason I have done this is follows, because what do you know about this guy here?
Variance.
Yeah, exactly. This is the variance of xi. Okay? And we are told that the variance of xi is sigma squared. Okay? And we are also told that the expectation of xi is mu. Both these are given in the question, right? All right, so this becomes k sigma squared plus mu squared in brackets minus sigma squared. Actually, mu is 0 in this case, so this guy here is equal to 0 because we are assuming the population mean is 0. It says mu equal to 0 in the question, right? So what you have is k multiplied by n sigma squared minus sigma squared, right? And this is 0 if and only if k is equal to 1 over n. Right? Do you follow what I've done? So the answer is the following, that k hat equal to 1 over n not k hat, I mean, what am I doing? I'm sorry, I'm lost. Sigma squared. I need my ink. I meant sigma squared, not k hat. I meant to say I meant to say sigma squared hat is unbiased for sigma squared, right? So this should say sigma squared here. Okay. Okay. Alright guys. So sigma squared hat with k equal to 1 over n is unbiased for sigma squared. Any questions on this, guys, or no? Are you okay with this, or everybody okay? Yes? Alright, the second part of the question is to assume normality and show what the sampling distribution is. So let me show you how to do the second part. Second part of question 8. Alright, this is, I forgot to put question 8 here. This should have said. I'm doing question 8 here, okay? Now the second part of question 8 is asking you about the distribution of this. Now to answer this, you need to really need to know the stuff I taught you. Now I'm going to do the following. I'm going to divide xi squared by sigma squared and multiply by this. You see what I've done here? I've divided by sigma squared and multiplied by sigma squared. So this becomes this. Now let me check your memory. Do you know anything about this? If you look back in my notes, either the printed notes or the handwritten notes, you will know something about this. It's something I taught you about 2 or 3 weeks ago. Yes? Yes, exactly. You remember? When I talked about the chi-square distribution about 2 or 3 weeks ago, one of the properties I gave you is that anything of this kind must have a chi-square distribution with n degree of freedom, right? So this follows the chi-square distribution with n degree of freedom C. See my notes on chi-square distribution. All right, so the answer to the question is that the sigma squared, sigma hat is equal to, so this is the answer. This is the answer to the second part of question 8. Okay? Are you okay? So it's really important you read through the notes. I talked about this about 2 or 3 weeks ago when I talked about the chi-square. There's 2 sampling distributions, the chi-square and the t, student's t distributions. Yeah, okay. All right, can you do 7, please? Now, 7. All right, for question 7, can you use this form? Remember, I gave you 2 definitions for sample variance. This is the unbiased version. Remember, this is the unbiased version, and I also gave you a biased version. But for question 7, can you use this, please? Use this as the definition of sample variance, which is the unbiased. This is the unbiased version of sample variance. Yeah. Okay, use this. Okay. This question is again to do with the chi-square distribution I talked about. So let me show you, and we are running out of time, so let me show you this quickly. I will just do part 1, and part 2 you can look up the solutions online for part 2, but let me just show you how to do part 1 of question 7. Alright, so question 7, part 1. So we want to find the probability that, that the sample variance is between 25 and 60, right? Now, in this question, n is what? N is the sample size, which is 10. So 10 minus 1 is 9. Okay. So you can write this as 9 times 25 You see what I've done? I have multiplied by 9 across the inequalities. All right. Now the next thing I'm going to do is, if you look at the question, guys, it says you have a random sample of 10 from a normal with mean 48 and variance 36. So I'm going to divide by, you'll see in a minute why I'm doing this. I'm going to divide by 36, which is the sigma squared, or the variance. Now, if you look at this term here, once again, if you look at my notes, on chi-square distribution, you will see that this guy here has a chi-square distribution with n minus 1 degree of freedom, which is 10 minus 1 here. Once again, please see my notes on either the printed notes or the handwritten notes. Both of them contains on the chi-square distribution. Okay, you see that this anything of this kind where you have the sum of the squares divided by the variance, which is 36 in this case, as a chi-square distribution with n minus 1 degree of freedom. So what you have is the probability that 25 divided by 4 less than chi-squared 9 divided by 15, sorry, less than 15. So this is what you have, and this you can read, you can compute this, using R, right? So this is the first part. I don't know, did you guys follow what I said? I just used one of the properties I gave you in the class, in both the printed notes and the handwritten notes, that something of this kind, where you have a sum of the squares divided by the sigma squared. Sigma squared in this case is the variance, right, equal to 36, has a chi-square distribution with n minus 1 degree of freedom, which is 9 in this case, right? Good. So the final answer is this, and this you can read using R. Okay. Are you okay, guys? So can you do part 2 by yourself, and if you should get stuck, look at the solutions online. Okay. I'll see you guys next week. Any questions, just feel free to email me 24/7. Okay. Yeah, okay, thank you. Thank you, Ted. See you. Have a good weekend.